Okay, so in this video I'm going to be reviewing rates before we get into some more complicated concepts for derivative. Okay, so today I bought my yellow bunny here a new pogo stick, and he wanted to test it out. So I made a graph of how far from me, or point 0, my bunny was at 0 seconds, and then I plotted points for how far he was after, I don't know, maybe 10 seconds. So as you can see from this graph, he moved away from me and then he came back. If I wanted to find his average rate of change, or basically his average speed from this point to this point, I would use the slope of this red line over here. And if you remember from your algebra classes, the formula for slope is change in y over change in x. Or in other words, y2 minus y1 over x2 minus x1. Now, let's say I wanted to find how fast he was going at that one point right there. In this case, we would be solving for the instantaneous rate of change. Well, the problem with using the above equation would be that at that one point, y2 and y1 and x2 and x1, this would be equal to 0, and this would equal to 0 also. And now we have 0 divided by 0, which is indeterminate, so we don't really know what that means. Instead, we could think of it as maybe the limit that this value approaches when y2 and x2 are not equal to y1 and x1, but really, really, really close. So we could think of it as the change in y over change in x when this value is super small. And same with this one. Or actually, this one doesn't have to be super small, just this one. Because we can't control the change in y because our function is already given. But we can change how small the gap is between the 2 points that we choose. Now, if you think of this geometrically, you can notice from this graph that the instantaneous rate of change is equal to the slope of the line tangent to our function at this point.